Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. In this video, I've been asked to prove that the solutions to this generic quadratic ax squared plus bx plus c equals 0, that the solutions to that are x equals negative b plus or minus root b squared minus 4ac on 2a. Now, you may recognize this solution as what's referred to as the quadratic formula. And it's basically the formula that gives you the solutions to a quadratic here. Anything with a polynomial that's to the power of 2 we refer to as quadratics. So the formula that gives us the solutions we call the quadratic formula. So in essence, being asked to prove this result, we're essentially being asked to derive the quadratic formula. Now, I think that's a worthy thing to do, because whilst a lot of students just memorize this formula, I think it can be beneficial to understand where the formula comes from. And that gives you a bit of a deeper understanding of what's going on. But I think it also has the benefit of, if for whatever reason, say you're in an exam and you're having a mental blank and you can't remember what this formula was, knowing how to derive it will give you that extra chance of getting the question right, because whilst it might take a little longer, you can work through the steps to derive the result and then still apply it to get the correct answer. So I think it's always worth not just memorizing formulas, but also understanding how to derive them. I still think it's probably worth memorizing it, because that way you can apply it more quickly under the time pressure of an exam. But I think what we're about to do here is still a very valuable exercise to do. So if you do find my explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, be sure to subscribe to my channel so that you can stay in the loop. Now, the way we're going to go about deriving this is we're going to use a technique called completing the square. And that's probably something that you learned how to do if you've dealt with quadratics. Maybe you would have learned that, say, in Year 8 or maybe Year 9. And that completing the square technique, it's a handy technique to deal with what are called monic quadratics. So quadratics where what's in front of the x squared is a 1. Now, we don't have a 1 in front of our x squared. So that kind of hints what the first step is going to have to be of our derivation, because if we're going to use this completing the square technique, we're going to have to divide everything by a to make sure that what's in front of the x squared is a 1. So let's do that. So step 1, divide everything by a, so we'll get just x squared plus b on ax plus c on a is equal to 0 on a, which would just be 0. Now, the next thing we do when we're completing the square is we move our constant over to the right-hand side. So the one item that doesn't have an x squared or an x after it, that's what we want to move over to the right-hand side. So we'll get x squared plus b on ax is equal to negative c on a. Now we're ready to complete the square. So if you're familiar with this technique, you would have learned that what you do is you take what's in front of the x, you divide it by 2 and you square it. And you have to add that to both sides, both the left-hand side and the right-hand side, to make sure you haven't changed the equation. So here we'll get x squared plus b on ax. Now we're going to add half of b on a would be b on 2a. So we just write b on 2a, and we want to square that. And because we did that to the left-hand side, we also have to do that to the right-hand side. And maybe what I'll do now is I'll just clean up this right-hand side a bit. So that's going to be equal to, I might just write this item first, just so we have something minus something else. So if I square the top and bottom here, we'll get b squared on 4a squared. So I've squared both the 2, 2 squared is 4, and the a squared is a squared. And then we go minus c on a. Now what I'd like to do here is get a common denominator so that I can bring this together. So I'll get b squared, and if I want this to also be 4a squared, so it's a common denominator, I need to multiply the numerator by 4a. So we'll get 4ac over 4a, all of that, so each one is over 4a squared. So now I can bring that together, so we'll get b squared minus 4ac all over 4a squared. And this, we can kind of see at this point that we're kind of on the right track, because we've got a b squared minus 4ac here, and that does appear in our final solution. So I think with a bit more work we'll get there. Now what we can do over here on the left hand side, the reason we took the middle term and divided it by 2 and squared it is because now we can write this as x plus b on 2a all squared. And if you wanted to check that, you could expand it. Maybe I'll just do that over here, because the way you'd expand this is you'd go the first one squared plus twice the product, which would be 2b on 2ax plus the last one squared. That's how you'd expand that. So you get b on 2a all squared. These 2's would cancel, so you get x squared plus b on ax plus b on 2a squared. X squared plus b on ax plus b on 2a squared. So we haven't made any mistakes here. We've kind of applied this completing the square process correctly. It's always worth checking where you can. So now what we can do is we can take the square root of both sides, and that will get rid of this square up here. So we can write x plus b on 2a is equal to, and we need both the positive and the negative square root of b squared minus 4ac on 4a squared. And maybe I'll bring over this b on 2a, so we'll get x equals minus b on 2a plus or minus, and I'll just take the square root of the numerator and the denominator, so we'll get the square root of b squared minus 4ac divided by the square root of 4a squared. The square root of 4 is 2, and the square root of a squared is a. So this will also be on 2a. And now that we've got that common denominator, we can bring it together. So we'll get negative b plus or minus root b squared minus 4ac all over 2a. And that is the quadratic formula. That's what we were asked to show. So by using this completing the square technique on this generic quadratic, just by following the same steps you would do for any other quadratic, or at least a monic quadratic, we've derived a generic result that now we can use. We could use this for any quadratic we came across and be confident that we're going to get the correct results. So there you have it. If you've committed this quadratic formula to memory, that's good. I mean, that'll help you make use of it efficiently, particularly in the context of an exam. But I think now that you've seen this, it might be worth you working through it yourself, just having a go at doing this process and deriving this result, so that you can have the comfort of knowing that if you ever happen to forget this in the context of an exam, maybe the pressure results in a mental blank, whatever the reason, maybe you'd still have a chance because you could get to this right result through the completing the square process. So hopefully you've found that helpful and informative, and tick boom.